All right, hi, my name is Mike Goelzer. I'm from Docker, and I'm going to talk a little bit about Docker Swarm, our approach to orchestration. So, just by way of introduction, I thought I'd just take a moment here and sort of explain how I got into this stuff. Let's see, 2 years ago, I was a computational chemist. I was doing simulations of protein and drug interactions, and we were doing these simulations on mostly CentOS clusters using some kind of, I guess, sort of ancient Red Hat clustering technology. And this was about the time that Docker started to become popular. And so that was sort of how I first got interested in this stuff. And one thing led to another, and now I work at Docker on orchestration. I'm a product manager, and so that was my evolution into this stuff. What I'm going to do tonight is basically try to cover three things. The first is explain what is Swarm. A lot of people don't know about it. There are some other orchestration frameworks out there. Kubernetes has gotten a lot of attention recently. There's probably a dozen other ones though as well. So I'm going to try to explain what is Swarm, because our approach to orchestration is really much different than many of these other systems. Then I'm going to show how you would set up a Swarm cluster, because it's actually very simple, and I think that's one of the big advantages of Swarm. It's much easier to set up than any other system that I've seen for container orchestration. And then lastly, I'm going to present what I would call a real-world microservices demo application. People often ask me, how can I deploy a real application on Swarm, not just a demonstration app or a test tutorial type app. So I'm going to try to give you a taste for what that would look like. And everything I'm going to do tonight in that regard is in a public GitHub repo. It's well documented. I've got videos up on YouTube of everything I'm going to tell you tonight. So if you want to go home and reproduce any of this, it should be easy to do. And so that's where we're going. Let me just start out with a few. These are slides I usually do in a business presentation, the next 3 or 4, so they're very non-technical, but they're just designed to give you an idea of what is Swarm. In a single sentence, Swarm turns multiple Docker hosts into a single virtual Docker host. So let's try to look at what that means in cartoon form. Most of you are probably familiar with the normal Docker workflow. You're sitting at your laptop, you're using commands like Docker run, Docker PS, you may be using Docker Compose, Kitematic, even other tools that are designed to talk to the Docker REST API. And regardless of what you're using, those commands are going over the REST API to some kind of a server that's running the Docker daemon. We call it the Docker engine. Everyone else in the world calls it the Docker daemon. But this is something that is running on typically a Linux server, although soon will support Windows as a first-class citizen as well. And that's the workflow for a single host. What Docker Swarm provides you is the ability to talk to multiple Docker hosts. So in this case now there's 3 there at the bottom, but as if they were a single Docker host. And the way we do it is by putting this proxying layer up at the top. That's called the Swarm Manager. So the Swarm Manager simply looks like a Docker daemon, accepts exactly the same REST API. Client programs like Docker Run or Docker Compose can't tell the difference. And when a Docker Run request comes in to the Swarm Manager, it takes care of scheduling it to one of the nodes. And that's sort of the essence of the system, to make many Docker engines look like a single Docker engine with much larger resources. So just to cover a few features of Swarm, I already mentioned that the Swarm Manager does scheduling. So when a Docker Run request comes in, it will schedule it to a node that has free resources. It also does rescheduling on failure. So when a node goes down, let's go back for a second. Let's say that node 2 on the far right there were to go down. Those 2 containers it's running have to be rescheduled somewhere else on the cluster. In this case, there's only 2 other machines on the cluster, so clearly they've got to go to one or the other, or both of those 2, node 0 and node 1. But that's another feature that the Swarm Manager handles. High availability, we support multiple Swarm Managers. So in the picture I just showed you, it's a pyramid and there's one Swarm Manager at the top. But you can have as many Swarm Managers as you want, and that'll give you a degree of resiliency. Labels, affinities, and constraints, we'll see a little bit of this in the demo that I'm going to do, but in general we give you very fine-grained control over where your containers are scheduled within the cluster, if you want that. If you don't care, you just say Docker run to the Swarm Manager and it'll decide. If you care, for example, you've got a Windows container, it can only run on Windows servers, then you can specify that. And lastly, the other cool thing that we do is DNS-based service discovery. So this is a lot of fun. If you have a container called Redis and you're putting all of your containers on a network, let's say it's called MyNet, then the hostname redis.mynet will resolve to your Redis container regardless of where that container is. And if the node that the Redis container is on were to go down and Redis gets rescheduled to a different node, this name will track it. Not just the host name actually, but the IP it resolves to will move, so that in your application code you can always be confident that you're tracking wherever the currently running Redis is actually running. Now, since this is designed to be a little bit more detailed, a little bit more of a lower level technical talk, I wanted to give a picture of what a real swarm cluster looks like at kind of the engineering level. So, as I mentioned, there's let's start on the left here, that you have the Docker CLI, or again Docker Compose, some tool that talks to Docker. It'll send commands to what we call the Docker Manager, the Swarm Manager. That's this proxying layer that I referred to. By convention, it'll access it on port 3375. 2375 is the IANA registered port for Docker. We don't have an official IANA registered port for Docker Swarm, so we just arbitrarily added 1,000 to 2375, and so far no one's complained. So you'll be sending commands, and you're going to see this in the demo. You'll be sending commands like Docker run to port 2375 on the machine that's running the manager. And then that manager is responsible for dispatching commands to the nodes in your cluster. Here I have 2 nodes, node 0, node 1, and they're running the Docker daemon on the regular IANA registered 2375. Lastly, that thing in the top right corner, the KV, basically we require some kind of a strongly consistent key value store for Swarm to work. That's something we're aiming to eliminate in future versions, but at the moment we require some kind of key value store. Console, etcd, Zookeeper, those are the 3 we support out of the box. It's very easy to write your own plugin if you have some other type of store you want to support, but we have a requirement on that to for both the scheduler and for the networking to have a consistent key value store where they can store data. So this is what like a real swarm cluster looks like not just in a cartoon. I mean, this is still boxes and arrows, but this is a little more detailed in terms of what the port numbers are. And so I want to talk a little bit about how to set up a swarm cluster, and then I'm going to show you the example application. And there's really just 3 steps to setting up a swarm cluster. The first is you need to set up this external key value store. That's that thing on the over on the right there that I talked about before. So that's one step. then run the swarm manager container. That's very easy. I'm going to show you that. That's a single Docker run command. And then lastly, you have to restart your Docker daemons with a couple of additional options, which I will show you. So none of these are very hard. I'm going to blow through each of them in one slide. Here's how to start the key value store. It's a Docker run. The image is console. Again, you could have used etcd or zookeeper. Console takes a couple of parameters, server and bootstrap, that it needs to run in single node mode. So you're supposed to run these quorum-based systems, either 3 nodes or 5 nodes or some larger odd number of nodes. For the purposes of this demo, we're just going to have a single node console cluster. So that's how you do it. These options in the middle, restart unless stopped, is something I like to put on all my containers. It just says that if the container goes down, restart it unless it was intentionally stopped by the operator. -D, demonize, just means keep the container running even after the Docker run command exits. Port mapping, so 8500 is console's port. If you're going to do any kind of diagnostics or debugging with it, it's helpful to map that port out to a port on the host it's running on, just to help you access it and figure out what's going on. And then name and host name, just to set the name of the container. That'll become relevant later on when we look at service discovery. And UI-dir is a cool feature of console that a lot of people don't know about. You can get a web interface out of console if you just specify that. I'm not going to use that in this demo, but it's just a neat way to be able to debug if you're having trouble. You can just go to whatever port 8500/UI and you'll be able to see all of the key value pairs that are in console. It's a trick you might already know. By the way, I'll just mention for people who are taking photos of the slides, that's totally fine. These slides are already posted on the meetup page for this event, so don't feel too much pressure to capture them like as they go by. And you can also email me or ask me afterwards if you have questions. So that's setting up the KV, that's step 1. Step 2, run the swarm manager. Again, it's a Docker run. The image is just called swarm, subcommand manage. We're trying to get rid of this, but we currently require a discovery opt parameter which specifies the path within the key value store where you're going to store information about all the nodes in the cluster. So that's a little bit of a hack in current versions of Docker. We'll hopefully smooth that out, but you need that for now. And then the last thing is the key value store itself, right? Because the Docker manage, the swarm manage container needs to know where this consistent key value store is, because that is the whole point of having it. And that port mapping 3375 to 2375, that kind of harkens back to that diagram I showed you back here, where, you know, again, swarm manager by default is listening on 2375. A little bit of a historical relic there. We like to map it to host port 3375 to avoid conflicts with other ports. So that's what's going on here. And then the third step is just restart your Docker daemons with a few extra options. Normally the way you start the Docker daemon, and it's a little bit different on systemd versus sysvinit, so I'm a sysvinit guy. Hopefully systemd people won't attack me. But you need to, whichever system you're using, you just need to pass 3 options. That first one says listen on TCP port 2375. That's so that machines outside of machines in your cluster can actually reach the Docker daemon on each of the nodes. Then the second and third ones are about telling the engine or sorry, the daemon, where to find that consistent key value store. And cluster advertise is just, again, once you contact the key value store, you need to tell it, if you're a node, you need to tell it how to call back to you. And so we just specify the Ethernet interface colon the port number, which again is always 2375 for Docker daemons. Okay, so that covered how to set up a swarm cluster. Now what I want to do is walk you through this example repo that I've created to demonstrate like a sort of kind of real world app. That you can go home, or actually right now if you're on a laptop, you can clone that repo, that URL right there. That's completely public. Start with the file called how-to if you want to reproduce what I'm doing in this demo. And as we go along, I'm going to show you that how-to file and how to use it. And I'm also going to later show you some YouTube videos that show each of the steps. So if you miss something I say, everything's linked from this PowerPoint. But basically, what this demo app's going to do is the goal is to demonstrate a few things. First, how do you set up a swarm cluster on Vagrant or AWS? I'm not going to talk about AWS tonight because I think for these meetup demos, it's better to have something that's completely can work completely air-gapped. So I'm just going to do the Vagrant version, and actually I have VMs already running on my laptop here. But I have an AWS CloudFormation template if you'd like to try the same demo on AWS. It works exactly the same way. I'm going to show you load balancing with interlock, which I guess Alvin already showed you, but it's a really cool load balancing solution, and I think this will give you another perspective on how to use it. And then I'm going to show a little bit about the DNS-based service discovery I mentioned earlier. So this is the architecture of the application that I want to talk about. Basically, let's start from the top and work our way down. There's an interlock load balancer. And interlock, again, is just an event listener that dynamically reconfigures HA proxy or Nginx. So in effect, it's an HA proxy load balancer sitting in front of multiple web containers. I'm going to show you in a second what those web containers are serving from a user perspective. Each of these web containers has a Redis queue. They accept information and then transiently queue it in a Redis instance. And then below the dashed line, what you have are asynchronous background workers that dequeue the work items that are coming up and that are being enqueued in these Redis queues and process them and then commit them to a Postgres store. That's that cylindrical thing at the bottom. And lastly, there's a results app which will show you the contents of the Postgres store. So what the heck does this thing do? Okay, the purpose is to enable people to vote between two options, cats or dogs. It's obviously a really trivial application, but again, the point is just to show how you would deploy an application that needs to horizontally scale. So each of these web containers is just running this page. And I'll show you this live in a bit, but it's just a voting page. You can pick between cats and dogs. It cookies your browser so you can only vote once. And at the end, it will tally, which one. Which one won. W-O-N. Anyway, you get what I mean. This is the results app. This is the one that's also running on the Postgres machine. So this is kind of like an admin interface. It's just showing you what is accumulating in Postgres as votes are coming in. So I just want to go back and say a little bit more about how this application is set up, and then I'm actually going to attempt to demo it for you, which I'm sure will fail, but I'll do my best. So I just, these red IP numbers are Docker overlay network IPs. So if you're not familiar with Docker networking, what we do is you turn it on, and then each of your containers gets an IP address within a private subnet, in this case 10.00.x. That's going to become significant in a moment when I show you how service discovery works, because basically names like Redis2 are going to resolve to IP numbers like 10.0.0.6, and then 10.0.0.6 is going to be reachable by any of these other containers within the application. So the way that Web2 is going to find its Redis queue, the Redis queue specifically created for it, is by looking up the host name Redis2, resolving it to this number, and then doing Redis connect, whatever language you're using. There's some function to connect to a Redis store, and it's going to give it that IP as the host name. And same thing for the workers. They also need to find all of the Redis queues so that they can continuously scan back and forth and dequeue votes that are coming into the Redis queues and process them for deduplication, and then commit them to the Postgres store. Lastly, the boxes that I've just added show the physical hosts on which, or sorry, not physical, but physical or virtual hosts on which each of these containers are running. You may be familiar with the school of thought that you should manage your infrastructure like cattle rather than pets. I'm a complete advocate of that, but in order to make this demo simple and comprehensible, I didn't do that here. Instead, I pegged different sets of containers to specific hosts just to make it like understandable. So that's the model we're going to go with. But in principle, all these containers could be running on a single host with a lot of resources, or they could be broken up in totally different ways. It doesn't matter as far as the overlay network is concerned. So I just want to talk about service discovery a little bit for a second, and then I'm actually going to show you the app. So as I mentioned, names like Redis1. So when you create a Docker network, you give it some name. I like to use the name mynet. You could use any name you want. Then names like redis1.mynet will resolve to IP numbers. Like in this case, 10.0.0.23 might be, So basically, this is a loop that exists in the worker code. And all it does is loop through Redis number.net, and that number, I in this case, just keeps increasing, and then we try to resolve each of those names and see if we get an IP number back. Because this is in Java, the way that it indicates that there's no that there's no IP is by throwing an exception, so unknown host exception. So we ignore the exception. It's a little bit of a weird model, but that's kind of the Java way. But the notion is you would build up a table in memory like what's on the bottom right there, and what you would end up with is a list of all of the Redises that are currently active in the cluster, all of the Redis containers, and what their overlay IP is. And then once the worker has that, he or she, however you want to think of the worker, is going to just scan through all of those available containers and dequeue votes and do processing on them. So here's the part where I want to do the demo. I have no idea how this is going to go. I've done this demo many times at home. I have never done this demo in front of a live audience before, which virtually guarantees it's going to fail. But as a hedge against that, I've recorded 5 screencasts, which are on YouTube at these URLs. And again, you can get this from the page for this meetup, so, or you can photograph it and type those in. But I'm going to attempt to do this demo, and let's see how far I get. So let me just start by saying I'm not going to do step 1. I'm going to show you the commands for it, but I'm not going to do it because it takes about 30 minutes on this laptop. I'm also not going to do step 2 because it takes a substantial amount of time too. But again, I'll show you the commands for it. Step 3, I'm also not going to do because it takes... Hold on, I know. In fact, I'm not going to do any of them. Anyway. Step 4 and 5 are the ones that I'm really going to do, where I'm going to show you how to start up the demo app containers, and then I'm going to show you how to use the demo app. And I would refer you to these videos. I had a lot of fun with ScreenFlow, just doing like special effects. So you should really watch my videos. They're awesome. But just truth in advertising, we're just gonna walk through the commands for the first 3, and then we're gonna. Oh yeah, sorry. Okay, and then we're gonna actually look in more detail at 4 and 5. So let's see if we can get this a little bigger. How do you feel about that? Good. Okay. People like it. All right. Okay. So I just want to back out of this for a second and just explain where I'm coming from. This is the repo that I keep encouraging you to clone if you want to try to reproduce this demo. And if you do clone this repo, what you will see is there's a how-to file, and this how-to file has if you just start on line 1 of this how-to file and just follow the instructions like it's a tax return, like just, like just line by line, literally follow the instructions, you should get to the same outcome that I'm going to show you. And if you don't, you can complain to me because my Twitter and email are on the last slide, so you have a lot of opportunities to complain. For better syntax highlighting though, I'm going to show it to you in VI. Okay. Like I said, I'm not going to show you the vagrant up part. There's a vagrant file in this repo. When you run vagrant up, it will bring up a bunch of VMs, which look a lot like that. Basically, it's the VMs that, let's see, if I go back to here, so those gray boxes that I promised you would be different physical or virtual hosts, those are the VMs represented in here. I didn't do all 5 web and Redis containers. I just don't have enough memory to do that. So what I have are 2 web and Redis containers and 1 worker, a Postgres, a results app, interlock, and a swarm manager and console. If Docker wants to buy me a laptop with 64 gigs of RAM, I would be happy to to do more. But I think this will at least give the impression. So if we were to do vagrant up with the vagrant file in the repo, you're going to get these machines. And these are just Ubuntu machines with Docker 110, our latest release installed. Everything's very transparent in the Docker file. I'm going to skip the AWS stuff, although it's well documented and I've tested it. I've made AMIs. Like, you really shouldn't have any problems if you want to go that route instead. So now there's a set of commands to create the swarm cluster, and the first one is creating the KV, that console instance that the consistent key value store that they need to synchronize on. So I have already done this step. Yeah. So console. So let me back up for a second. Docker, when you set Docker host to 190 whatever, that IP .11:3375, that's the manager IP. As I mentioned before, the manager listens on 3375, and .11, if you were watching closely, .11 is the machine where I'm running the manager and console. So I first set this environment variable, which means every time I type Docker, it's going to talk to this host instead of, by default, Docker would try to talk to the local Unix domain socket, which in Mac OS is meaningless because there is no Docker socket on this machine. Okay, so that's where we are with running console. The Swarm Manager here I have also already started, and I have also done the most error-prone part, which is to create the overlay network. So if we do Docker, oh, is this readable in the back? Is that readable? Okay, okay. All right. If we do Docker network ls, you will see here that my net was already created. This is what tends to be one of the most error-prone steps, so I just did it before the demo. You can call that cheating if you want, but okay. So these are the parts to get the cluster up and running that I've already done. Again, there's great YouTube videos. I mean, great because you know I made them. I love them. That will walk you through those steps. Now, again, the build instructions. This was like I think the number 3 that I said. Okay, I'm also not going to do this live because it's just very time consuming. I mean, these are just building from Docker files, and you know they. Some of these are like Java apps, and they just pull in like a million dependencies, so we're not going to do that. I'm just going to explain what I have done here is web vote app is the thing that runs on each of those 5 web containers I showed you. It's the thing that collects the votes, and so what I do is I build the image directly on each of the machines. So as I told you, I'm only going to do 2, but if I was going to do 5, then there would be 5 of these. But I just build the image directly on the machines where it's going to run. Now, let me just clarify one thing. Normally, we recommend, like strongly recommend, that the way you work with Docker is you build your images and then you Docker push them to Docker Hub, or you can push them to your local registry if that's your preference. But you push them to some registry and you work with them that way. Like, don't build images directly on one machine. It's just too hard to keep track of. Since this demo is supposed to work even if the internet connection goes down, I didn't want to be reliant on Docker Hub, so that's the only reason I did this. But there is a much easier workflow, and actually Banjot's going to talk about an even easier workflow, which is our supported version of Docker Hub, and will make your life even easier if you're willing to. So the image builds that I'm going to skip, and here's where I'm going to try to actually do the. Oh, okay. So let's start with interlock. I'm going to copy and paste these commands, and I'm going to talk about what they are. That's clear. So again, let's just start with a Docker PS. There's nothing running except console. Now I'm going to paste in the command to start interlock. So just really briefly, what does this mean? Interlock's going to be running on its own machine, which is .12. If you look this yellow bar up here, look at the top right, the designated machine for that was 33.12. So that's the -H part. Then run, again, I've already explained restart unless stopped. The -P8080 is a port mapping. I want to call this container interlock. I want it to run in daemon mode, and ehas/interlock is the image name. He requires 2 parameters. One is the swarm URL, so that's 33.11 in this example, :3375. Again, that's where the swarm manager is. And the other is plugin HAProxy start. It could also be plugin nginx start. Those are the 2 that interlock supports right now. We'll do that, and now that one's up and running. Now the next step, this is going to be a little confusing, but basically I'm going to start a Redis. I'm going to start Redis 01 and web 01 on one physical machine, which is called front-end 01. And then I'm going to do exactly the same commands again to start Redis 02 and web 02 on front-end 2. So if you're trying to think about it in terms of this picture, basically I'm going to start this with 2 commands, and then I'm going to start this with 2 commands. We're not going to do the other 3. So again, copy those. Paste. So I'm sure most of you have worked with Docker, that these long numbers of the container IDs, it means the command was successful. Okay, now I'm going to start the asynchronous background worker. So again, this is this guy, and we want to start him on .200. And then I'm going to start the results app and Postgres. So Postgres, results app, both running on .251, and this is Postgres. Okay, so let's clear Docker PS. Okay, we've got a lot of containers running now, and they're the ones I just started. So now we can finally use the app. There's one small catch here. I recommend you, for cosmetic reasons, update your etc host file so that .12, which, as you'll recall, is the machine where interlock, the load balancer, is running. I recommend you give it some name like votingapp.local. It's not strictly necessary, but I think it's aesthetically more pleasing. So let's assume you've done that, as I have already on this machine. To test the app, you can browse to votingapp.local. So let's go to Safari here. Let's try to make this bigger. Let's go to votingapp.local. Okay, we've got the cats versus dogs. So let's see. Before we do any voting, let's quick bring up. All right, I don't know if that's going to work or not, but let's vote for cats. And then you can change your vote back and forth between cats and dogs. Oops. So if you look, okay. So if you look at the bottom here, it's really hard to see. As I switch back and forth between votes, what it's going to do is resubmit the page. And so you're going to have, if you look at that line at the bottom, you're going to see that it's getting load balance between web 1 and web 2. It should just be random. I actually can't see well enough, but I'm positive that in the YouTube videos it does that. So, and then let's just go to the results app and see if our vote got counted. Oops. 50-50. Hold on. Uh-oh, something's not working correctly. What?
You voted on both.
Yeah, I know, but what it should be doing is counting only the latest vote. So in other words, you go back and forth like this, right? Okay, it should only count cats. And in fact, we can go into Postgres and see what it thinks is going on. How am I doing on time, Banjot? Oh, okay, great answer. Yeah. Okay, I won't take too much longer. Let's just see if any of these are getting in. Ooh, no. Okay, so some part of my demo is failing. The web containers came up, but something's not working, I think, with the, I'm going to guess it's with the asynchronous background worker is not correctly dequeuing votes. So this is the point where I will weasel out and say, if you want to see how this should have worked, you could watch this beautiful video, which I think is only about a minute long. Yeah. Okay, let's skip the Etsy host stuff. That's not that important. So you can see this is the same place I was in the README file. Now we're gonna browse in Safari to that URL like I just tried to do. And okay, you got the same page again. Okay, now let's see the results in Postgres. This time it's gonna work because you're watching a video. Yeah. Here's my slow typing. I should have sped this up. Yeah. No, I know this is gonna work. All right. So we voted for cat, and A is cat in this table. Now we're gonna toggle back and forth. Each new vote will get enqueued into a Redis queue, and then the last one is the one that will. Oh, and this again should be changing back and forth. The last one is the one that will take precedence. So now we're just going to do the same select again. Okay, so it switched to B because we switched to dog this time. So anyway, so that's basically the demo. Obviously, I haven't fully ironed out all the bugs, but it will work. You can watch these videos, and that's where it's at. I will just put in a quick plug. This is my last slide for my colleague Jerome, who's in Europe right now. He's also going around doing swarm demos. He has a really cool swarm demo that is based on Bitcoin mining. He doesn't actually mine Bitcoins because apparently in 2016, like the amount of computational power you need to get even a fraction of a Bitcoin is like not realistic in a 45-minute laptop-based workshop. So he mines just some imaginary coin. We just compute some hashes, but it's a really good example of how to do batch processing. He's also really interested in chaos monkey type stuff. So like, can we have a cluster and then just kill nodes randomly and have it be resilient enough to just continue functioning? And he does that with Swarm. He also demonstrates some cool stuff like the elk stack for logging and metrics, and he has some other load balancing patterns that I haven't talked about here. So that's the end of the demo. Sorry it didn't quite work, but hopefully it gives an impression. Is there time for questions? Any questions?
What recommendations do you have for doing session management across these apps that are load balanced? If you were to do session management.
Yeah, you would probably need to back that by some type of database. The way this simple one works is just cookies each browser, but obviously someone who wanted to cheat could just delete the cookie. So, but yeah, you would need to back that by your own database and sessions library.
Yeah. What's the largest anyways, like scaled swarm of production so far?
Yeah, good question. So we did a scale testing at DockerCon, and we got it up to 1,000 nodes and about 30,000 containers. What we were measuring was once you get to that scale, what is the incremental time it takes to schedule the 30,000th and first container? So like that, that marginal container, how long does that take? And our goal was to have it take under a second, and it did. There's obviously a lot of additional scale testing that you could do and that we're pursuing internally to understand what's the behavior of the overlay networking at that scale, and some of these other features like service discovery. So basically we're trying to push scale beyond 1,000 nodes, but also fix problems that we've noticed at the 1,000 node level. And but that's a big goal for us, to really be able to go to high scale, because we have a very simple system, and one of the advantages of a simple system should be that it can scale really well.
If I have also used console in my application, I put my application in a container, would that potentially, using the same port number, would that potentially in conflict with the console used by the manager?
Yeah, so there's no requirement that you use console on 8500. That's just by convention. So if you want to have a separate console instance to do your own work, well first off, if that console instance is on the software-defined overlay network, I don't see how that would have any effect, right? Because the console I deployed here is not on that network. But if you had any concerns, you could just remap the port to 8501, or console has actually a bunch of things. It has 8400, I forget what it does with that. It has a DNS discovery port, a 53 UDP. So, but yeah, you should be able to use console just fine. Yeah.
This clustering works only on an L2 domain, right? Not an L3.
Yes, that's right. That's right. Well.
Physically co-located almost, basically.
They don't have to. Yeah.
Almost.
Are you asking if the overlay network? Sorry.
The overlay you have is also in a physical L2.
Yes. Yes. That's true. There's no requirement that. I want to defer to the networking guys before I give you a wrong answer. But if you come up to me afterwards, I'll put you in touch with them. I think the answer is yes, you're right. It would only work on L2, but
From the choice of address you have, so
yeah.
it's not an accident that all of them are.
Yeah, well, I just picked the simplest default addresses, like for the I mean, you can customize the overlay networking extensively, and so I just picked the simplest options for this demo. But for specific questions, I always defer to Madhu, who didn't. Told me he'd come tonight and back me up, but yeah.
But there are two options. You could use a VS and then use some kind of overlay, like VXLAN. You still
VX
also
separate
don't have
one.
your underlay
Right.
SAP, or you could do proper routing in containers and just have learning solution.
But many of his discovery thing actually would not work if it goes through a routing thing.
It doesn't
That's
care. It's just you lose connectivity. It's not legitimate here because it doesn't do anything in addition to learning. If you do proper routing, it will work. We did.
Any other question? Okay, thank you very much.
Still awake? All right. Thanks for sticking around. I promise I will make this short and sweet. Everyone warned me before I came. They said you should not go to meetups and talk about commercial products. They're going to throw tomatoes at you. So I just want to check. Anybody have a tomato? Okay, just making sure. So I literally want to give you kind of a 5-minute pitch on something that at Docker we were very excited about, which was the announcement of Docker Data Center. Some of you may have seen this. Oh, by the way, my name is Banjot Chanana. I run our enterprise products at Docker. So I've been working closely with folks like Mike and a lot of our open source team to take our products and figure out how to get them in the hands of customers who run kind of large data centers, enterprise class environments. And so a lot of the focus for us is to take the simplicity of Docker and the usability of Docker that many of you know and love and put it in the hands of not just a enterprise team, but an enterprise ops team. And so that's an entirely different kind of dilemma than trying to make it work on, say, a laptop or even a small environment. So the good news is that we've been working on this for a while, and we're very excited at this announcement around Docker Data Center, which is basically taking a lot of the goodness of Docker and bringing it to enterprise environments, on-premise data centers or hosted virtual private clouds, and making it available for those folks, as well as providing the right places for that software to lay down in their environment. So just very quickly, the goal of Docker Data Center was to take all of the pieces, Swarm you heard about, you heard Alvin mention Docker Daemon or Docker Engine. He mentioned other pieces of the portfolio. What we did with Data Center was take all of those pieces and literally tie them together in a way that we knew would be usable and easy to install and deploy, but then also provide a way for all of those components to be pluggable in an enterprise environment, as well as adding some proprietary code around it in terms of being able to provide specific capabilities around authentication, authorization controls, role-based access control, single sign-on, and the like. So the focus for us around Docker Data Center was to take it from, hey, this works really well in an environment, to here's a validated stack that I can actually run in my ops environment and offer this up as an operations team back to my development teams to give them the flexibility, the usability, and all of the agility you get with Docker, but in a controlled enterprise environment that many of our customers live in. So we took things like Docker Engine. We made sure we provided the container runtime there. Is it still on? There it is. We took Swarm, we made it super easy to install and deploy, and then we added some capabilities around security, specifically capabilities around authentication, role-based access control, tying into LDAP, Active Directory, etc. We also built the registry service. So we have a open source component called Docker Distribution today. We took that component similarly, and we built on top of it the same security protocols and integration points so that we could provide that. So I know you guys, it's late, and you've probably seen enough slides to last you a long time. So I have more slides. Oh, slide junkie that you are, Alvin. Look, all the marketing slides I will make available to you guys. It's all really fun and good. The key things you should take away from this, one is that Docker Data Center took a lot of the existing capabilities, built the enterprise functionality around it, but we did not lose compatibility with Docker APIs. So everything we did was native Docker API. That means the Docker run commands that you saw Alvin and Mike run to deploy their respective apps, you'd run exactly the same commands against a Docker Data Center deployment. And those same commands would then be checked for authentication privileges. Who are you and what are you doing? Authorization to make sure you're allowed to do what you're asking to do. I want to run this container, I want to deploy this app. And then auditing to make sure that we know who did what after the fact. And then we're adding more capabilities as we go. So that's kind of the left side here. The right side is we made sure we allowed for integration points that we know big enterprises have. So they want custom storage, they want to integrate with their existing monitoring tools, they want to run their specific networking. Those are plugins that today are available with Docker Engine that you can also use with Docker Data Center as well. So that's the crux of it. What I thought I'd do is let's flip over and just show you a little bit about how this looks. So first, there are really two components to Docker Data Center. One is the registry. The registry is where you store your Docker images. This is where individual developers can have their private space to upload their images, the images that represent their applications. You can also collaborate as a team on, say, a collection of microservices. So you've got an app that you've divided up amongst multiple teams. So you can have a single place where that team can collaborate on their application. And so what we did with Docker Trusted Registry was focus around the notion of taking what today is Docker Hub, where you can do this, and actually allow you to run that on-prem inside your data center in a managed environment, virtual private cloud, or inside on your own premise. And so we focused a lot on making sure that someone who starts in Docker Hub, when they see Docker Trusted Registry, would see very much the same look and feel and the same usability. However, the key component is we authenticate that user, we tie into the enterprise environment, we provide you with storage backends, integration to storage backends that we know big enterprises need. So let me give this a quick zoom in. So this is the dashboard for Docker Trusted Registry. This is already installed. What we did was try to give it give you enough information up front to tell an administrator, here's what's going on with your environment. And I should note that Docker Trusted Registry itself is built on Docker, so it runs as containers on a Docker host. So you can see the individual containers here that we've built out. Whoa. I know you did it to me, Alvin. I'm hoping. All right. For some reason, that decided to resize on me. Okay. I'm hoping that. All right. So let's take a quick look here at Trusted Registry. You can see here the repositories that I've got. These are my personal repositories as the user who logged in as admin. I've got repositories that someone has shared with me as a part of my team membership. So in my Active Directory, my LDAP, I'm part of a group, and that group can be mapped to a team. And so I can see specific repositories here. You can see the one that I've got. You can look at the details on it, see what tags have been pushed into this repository, and you can also set the settings around the repository itself, private or public. Similarly, you can then set up your organizations and your teams inside Docker Trusted Registry to represent the functional teams in your environment and how they work. So this is the registry side of the equation. This is where you store your images. Now for the kind of run side of the equation, I'll bring up, this might be a little bit harder. And I'm going to take a chance and try to unplug and let it resize and see if this works. Okay, a little bit better. Okay, so on the run side of the equation, for an operations team, typically the first thing they want to do is see what's running in their environment. Tell me how many hosts are in my cluster. If I'm running my swarm, what does my cluster configuration look like? Which are my controllers and which are my swarm managers and which are my replica nodes that are going to support that swarm manager? Tell me a little bit about the resources in that cluster and show me what's running. So if I've got applications being deployed, show me those applications as well as the individual containers, the images that have been pulled into the cluster, and then you can see I've got a 2-node cluster. So as an operations person, I get first visibility to the environment, and second manageability. So I can go in and now take one of my applications, say my voting app here that Mike had deployed, and if I want to actually take a closer look at this, you'll notice this is actually not started. So let's go actually start my containers here for this voting app. So as that starts up, fingers crossed. I did not do videos, so if it doesn't work, you can see here my individual containers for this app, and this is the same voting app that Mike deployed as well. I can go look at information about this. So if I want to see the stats, and this is going to gather information as we stand here. We'll eventually do something. You'll start to see that information populate in these screens. Alvin, did you jinx me? So moving on. So you can see the list of your applications, manage them very simply and easily. You can see the individual containers. So me as a logged in user, I see my containers, and I see the containers for me and my team that I'm a part of, but I do not see the containers for other teams that I'm not a part of. So specifically in here, we focused on making sure that kind of role-based access control throughout the system was enforced. You can see the individual nodes in the swarm. Can't manage or do anything because I'm not an admin in the system, so I can't actually do anything with them here. I can also see the volumes and networks and images. And you can see in here, again, we focused a lot on the user interface, particularly for an ops team who's not going to spend most of their life running containers. They're going to spend most of their life trying to troubleshoot what's going wrong with the environment. So we spent a lot of time focusing on giving them easy manageability. Let me deploy a container, let me create a volume, let me create a network, and give them easy dialogues to do that. However, we spent a lot more time making sure that they can see what's going on in the individual environment, and so they can drill into a specific container, see the specific details. This is just your Docker inspect on this container. So effectively everything running about this container you can see here in the screen. You can see got an error getting logs. You can see some stats around the container, and then if you need to console in, you can console in as well. So that's a quick overview. We're really excited to kind of get the stack working together, actually make it ready for large enterprise environments. Like I said, it's Docker native to start with, so this actually works with all the same Docker run commands and Docker compose files that you have today. So I'll pause there. I know it's late, but I'll take questions if folks have them. Yes?
What do you consider the competition to be for Docker containers and Docker data center?
Yeah, that's a great question. So competitively, I would say we run into a lot of other container management solutions. I think Kubernetes is typically one that we see quite often in the space. And I think it's largely because folks are still trying to figure out what is the kind of orchestration platform they want to use. And so, Mike and I spend a lot of time with customers jointly to talk about Swarm as a basis for the orchestration, and then, if they're looking for a well-validated stack, then here's the commercial offering that works end-to-end that we fully support. So in some cases it's Kubernetes, in other cases it's, say, OpenShift with Kubernetes in the middle of it. Sometimes we're up against platform as a service offerings, Cloud Foundry and others. So that's typically where we see others. Yeah. Other questions? Yeah. Last question. Sure.
So I'm trying to understand the difference between what Mesosphere is doing and what you guys are doing.
Yeah.
They claim to work in the space, but I don't know enough about the details.
Yeah, so the difference between Mesos and what, so is that particular to Swarm or just,
Just the question about how does it compare, is it competitive or the complementary?
Yeah, so they are trying to solve slightly different problems in that Mesos, and especially I would say Mesos and Mesosphere focused on the data center wide orchestration problem. So it's not just about containers, it's about deploying applications irrespective of container, VM, or physical node. We focus primarily on container. So when it's a container only space, then yes, we do see Mesos in an environment where we'll go head to head and people will compare us feature to feature. I think what generally differentiates the two is, especially in a container space, I think we focus a lot on not just the individual container, but now adding networking, adding other capabilities like control and management around it. That's where our focus is going to go, is kind of continue taking from the container up through to the application, so the set of services and then the full application deployment. I think for Mesos, they've focused in on providing the frameworks that you can do that for specific. I think big data is typically where we see a lot of Mesos deployment. So it depends on kind of whether you're looking for that specific niche or whether you're trying to do something hybrid. Then it typically leans towards Mesos. Yeah. Other questions? Yes.
So where can this be deployed and what is the footprint looks like?
Yeah, where can this be deployed? So it can be deployed in bare metal hosts. Virtual machines, so pretty much anywhere that Swarm works and Docker Engine works, so does Universal Control Plane. So the Docker data center is, like I said, all built on containers. So anywhere you can put a Docker host, you can actually lay these bits down as well and use them. Now, I will say for supportability reasons, we've limited the number of operating systems we support out of the box. So we've limited to Red Hat, CentOS, Ubuntu, and SLES. But that usually covers for the large enterprises what they're looking for. So and so it can be run whether you want it in a cloud provider in a virtual private cloud, or whether you want it on-prem on OpenStack or on bare metal works. All right.
What's the pricing?
Pricing is per node, so it's all on the website. I don't want to bore you guys with kind of pricing and packaging details, but yeah, it's priced per node and available today to trial, so you can go out and actually try it, download it, get it running, and then yeah, you can call us for volume pricing.
So Kelsey Hightower tweets a lot about the difficulty of container networking.
Yes.
What does he mean by that? And what can you add?
Yeah, I haven't followed Kelsey's post particularly around container networking. I think in particular around the Docker networking model. I think he's certainly made comments around,
He makes comments in general about every container network.
Yeah. So to be honest, I'm like Mike. I'm not a networking guru by any means. So I don't know, to be honest, like why he felt the container networking model, say, whether it's Docker or Weave or somebody else, was that difficult. I know certainly for Kubernetes they kind of stamped a very specific model, and that helps simplify I think the feedback we've heard is that model works if you adhere strictly to it. If you can't, and you've got applications that maybe aren't microservices yet or aren't ready to be put in a pod, then it's really hard to stick to that model. So, there's something to be said for simplicity, but there's also, I think, a fair bit of flexibility needed to get people from VMs where they are today to a container model. And having spent 7 years at VMware, I can tell you getting to VMs was hard. I think getting to containers, there's a ramp there. There's a learning curve, and it's exciting, but there's a fair bit of flexibility needed to make sure people can make that leap.
So what do you think about vMotion going into Continental today?
I didn't hear the news about that, actually. vMotion being intercontinental. That's good, because I worked in that feature about 4 years ago. I'm excited that it's happening, but in the battle between pets and cattle, I think pets are going to lose out. So, last questions. All right. Well, thank you very much. I appreciate your patience.